Hello students, hello and welcome to this video. In this video we will solve question number 361 to 370 of permutations and combinations. The link to download the PDF will be in description, as well as at the end I will show you how you can download the PDF from the website. There are other things on the website also, and I will show you how you can do that and maintain the updated copy of the books. So without further ado, let's get started. Question 361 says that let there be 9 fixed points on the circumference of a circle. Each of these points is joined to every one of the remaining 8 points by a straight line, and the points are so positioned on the circumference that at most 2 straight lines meet in any interior point of the circle. Find the number of such interior intersection points. An intersection point requires 4 points on the circle. Thus, total number of such points is 9C4, that is 126. Question 362 says that if a set A has m elements and another set B has n elements, then find the number of functions from A to B. For each element of set A, we can have n elements in set B. Thus, total number of functions would be n to the power m. Question 363 says that let A is equal to x, where x is a prime number and x less than 30. Find the total number of different rational numbers whose numerator and denominator belongs to A. So A is a set of prime numbers, so A would be 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29, because x is also less than 10. So we have 10 elements. We can form a rational number of the form p by q. Thus, we can choose these numbers in tensity two ways. But the rational number can also be of the form q by p. Thus, number of rational numbers is tensity 2 by 2, that is 90. One of the rational numbers will be 1 when p is equal to q. Thus, total number of rational numbers is 91. Question 364 says that find the number of all 3 elements of the subset A1 through AN which contain A3. So the number of subsets, in the subset we put A3, so now we have to choose 2 more elements out of remaining n minus 2 elements of the given set. This can be done in n minus 1 C2 ways. Pretty easy problem. 365. So this was 364, right? Okay, this was 364. Okay, 365 says that if the total number of m elements subsets of the set A1 through AM, this should be AM or this should be M, whatever, is k times the number of m element subset containing A4, then find M. This is M, okay? This is guaranteed to be M, so it's a typing mistake. Clearly, number of m element subsets is MCM. Let me read. No, this is correct. The set has n elements. We are constructing m element subsets. Okay, so the number of subsets is MCM. Now we follow the previous problem. The number of subsets containing A4 is n minus 1 C m minus 1. But it is given that MCM is k times n minus 1 C m minus 1. So we solve this and we get n is equal to mk. Question 366 says that a set contains even plus 1 elements. Find the number of subsets of the set which contains at most m elements. So number of subsets is 2n plus 1 C0, 2n plus 1 C1. This should be underscore, so it's a missing underscore. Instead of underscore I have typed minus. Then 2n plus 2 C2, and then 2n up to 2n plus 1 Cn. Let this be capital M. From the binomial theorem, we know that 2n plus 1 C0 plus, again it's a copy paste mistake. So up to 2n plus 1, missing 1 here, will be 2 to the power 2n plus 1, and we know that MCR is equal to MC n minus R. So 2n is equal to 2 to the power 2n plus 1, so n is equal to 2 to the power 2n. Question 367 says that Find the number of subsets of the set A1 through An which contain even number of elements. The total number of subsets is 2 to the power n. Half of these will contain even number of elements, that is 2 to the power n minus 1. Question 368 says that find the number of ways of choosing triplets x, y, z such that z is maximum of x and y. Z is greater than maximum of x and y, and x, y, z are in the set of 1 through n plus 1. So we let x is equal to n plus 1. X and y can be chosen in n square ways. When z is equal to n, this should be z. Okay, this should be z. When z is n plus 1, x and y can be chosen in n square ways. When z is equal to n, x, y can be chosen in n minus 1 whole square ways, and so on. So total number of ways is 1 square plus 2 square up to n square, that is n into n plus 1 into 2n plus 1 by 6. Question 369 says that in the decimal number system, find the number of 6-digit numbers in which digit in any place is greater than the digit to the left to it. So this is same as selecting 6 numbers from 1 to 9. 0 is excluded because if 0 is selected, that makes it the least and should be placed at the first bit, that make it a 5-digit number. So selecting 6 digits would be 9C6, that is 84. Question 370 says that find the number of 3-digit numbers of the form x, y, z such that x less than y and z less than equal to y. If y is equal to n, x can take n minus 1 values from 1 to n minus 1 and z can take n plus 1 values from 0 to n plus 1. Y can vary between 2 to 9. So the required answer is, this should be n minus 1 sigma n is equal to 2 to n minus 1 into n plus 1, that is 276. So those were the easy problems this set relatively compared to previous set. So now I'll show you how you can download my books. So you come to my website astrolocker.org and you can download the second book of algebra, third of trigonometry and fourth of geometry. This number indicates the date 2026, 5th means May and 20th means 20th May. So you can download these books, and when you download, there will not be date in the books. So you should add a date when you download it, the same date which is mentioned here. And when I update the books, I change the date, and periodically, maybe in 15 days, you can come and check if there is a new version. And if there is no new version, then it's okay. Otherwise, you can download and update your book. Fair piece of warning is that there are lots of typing mistakes in the books, as you know, if you have been watching my videos. So I'm working on fixing those, and slowly they will be removed. Apologies for that. So with this, I will end this video here. I thank you for watching the video, and we'll meet again tomorrow with 10 more problems on permutation combination. Till then, I will take my leave, and you keep practicing. Have a good day.